You can see the presentation on screen. Okay, all right. So today we'll have some fun, and this is a very important topic which we want to discuss. We'll discuss mainly about Bitcoin and the blockchain, which is nothing but data structure for Bitcoin. And believe me, not many people know about this technology, right? So I have taken contents from many slides, many places. Of course, there are some places where I could get a lot of nice presentation. Okay, and pictures. I prefer to use pictures or diagrams because it instantly gives you an idea about the concept, right? So basically these are the places where I could get some visuals. But what you can do is that you can actually, they're nice website which we should go and then explore if you have time. This one, I found it very good. So it gives you idea about how blockchain works, blockchain and Bitcoin works, and also gives you actual implementation details. All right, and other, I would think that you should read these two books. Okay, if you are interested, this book I have sent you. It's a pre-publication text was available. By it was made available by authors, so you can also download if you want. This book, of course, you'll have to buy if you want to read. So these are the topics we try to cover today. I think we'll not have enough time, but let's see. And all the remaining one we'll cover in the next class tomorrow. Okay, so question to you is that what do you think about Bitcoin? What is Bitcoin like? Or what is cryptocurrency in general? Have you used any one of you? You can always open account with some, there are some agents. Okay, that is just an interface for transferring money and then getting some, small portion of Bitcoin. That doesn't require much money, so you can always do that and then explore. Right, may not do any transaction, but just explore. Like you can open a demat account when you want to do share trading, and just explore. You may not do anything, but just explore what happens. How does it work like that? Okay, anyone has idea about what is Bitcoin? Well, every day you
Bitcoin
hear
is basically one type of cryptocurrency.
Pardon? One type of?
Bitcoin is basically one type of cryptocurrency.
Yeah, it's one type of cryptocurrency. Very good. Okay, what else? Now you have crypto, right? So what is see, currency is a currency. Currency involves money, right? And we have currencies like Indian rupees or dollar, US dollar or British pound and so on, right? So it has certain, it carries some meaning, right? And I am sure in your basic class on economics you would have read about money. Okay, so let's look at it. And when we say crypto currency, who is creating the currency and why? And what is the basis of it? And see, when we say Indian rupees or something, there is some government has, or the country has some amount of reserves or something. Based on that, current currency value fluctuates, right? A foreign reserves, for example, could be one, or could be amount of gold the country has in reserve or something that you can always read in the class of economics. But in crypto, what is there? You cannot say that crypto has gold encrypted form or something like that, right? So there has to be some basis, right? And who can create crypto? Anyone? Can you create a crypto company and say that this is my money, this is my company's money? Okay, so these are the questions that will come to your mind. It has come to my mind too, right? And so let's try to explore a basic concept, and we will get into technology because we are interested more in technology. How does it happen, right? So first, at the top level, what it is, and then we'll get into details. Note that one thing, there is a relationship between Bitcoin and blockchain. Blockchain is nothing but data structure for Bitcoin. Okay. Now, since it's data structure, it can be used in other cryptocurrencies also, or it can be used in other applications. So you find that blockchain has lot of usages, right? Like banks use blockchains, or insurance companies started using blockchains, and so on. Health industry is using blockchain, and so on. So, all right. Okay. So, and believe me that very few people understand blockchain and cryptocurrencies. I went to a conference, and then it turned out that I was talking to people around and asked some very basic question, and most of them were clueless. The reason is that crypto by itself, cryptography itself is a complex concept. Okay, not many people understand encryption. Forget about asymmetric key encryption. Okay, that we have studied in our class in detail, right? And then digital signature and so on. Now you are absolutely ripe to understand the concept of cryptocurrency, right? Which is based on cryptographic concepts, right? Of course, the Bitcoin is popular, but you note that you cannot use it. So far, it's not that popular that you go out on the street and buy half kg of tomato and want to pay say 15 rupees through Bitcoin. It's not so popular, right? And also it's also not so fast that somebody or a hawker will accept it, because it takes some time for confirmation. While you go out to buy coriander leaf or dhania, and then pay in, and I did that a week back, right? And I didn't have change. It was 8 rupees, and I paid by Google Pay. So those are called micro payments, right? So Bitcoin so far is not popular, or it's not gain acceptability, okay, for micro payments. All right. Okay, and you will see that possibly in some places in US, Bitcoins would be accepted for buying a cup of coffee, even the coffee cost say something around $5 or $7 and so on. Right? But otherwise, its use is largely for larger transactions. Okay, so first thing is that let's look at what we have studied. Okay, and how these are going to be used. So how these are going to be used, we will look at later once we understand the concept, and then we will see how we can apply this. So these are the hash. You all know about hash. Okay, these are cryptographic hashes, right? Okay, then we look at hash pointer. Hash pointer is nothing, will form a data set called blockchain. Look at small, for a few minutes we'll spend on digital signature, and of course symmetric key encryption. These are the technologies we use. Okay, almost everything excepting the hash pointer, which is nothing but a simple data structure. Okay, hash function you know, right? Take a arbitrary length message, a file or whatever you may want to take. It could be of any length. And then apply this to a hash function. Okay, this goes here, and what you get is fixed size output, right? That's what we studied. It usually is a 256, and one the algorithm we saw is Shaw algorithm and so on, right? So basically take any length of input m, and output is fixed length n bit hash. Okay, so this is n bit, which is kind of is a fixed size, right? For an algorithm, it's a 128 to 56 or could be anything else, right? But if you take this message m and give it to hash function, and then you will get set to 56 bit output. Give it again, same thing to hash function, you will get the same string. Okay, that's one property. And you suppose instead of m, you have m dash, which is maybe bigger than m. You give it to hash function, and output is again 256 bit output, right? And if you just change one bit in m dash, then you will see the output is again 256, but it's very different from earlier one. Okay, so that we all studied, right? And we have seen these characteristics like deterministic, every time it will give the same output for same input. Okay, efficient to compute, it shouldn't take much time. One-wayness, it means that given m, which you want to hash, and output of hash is so say something like y, or we call it x. Given x, output is y. Okay, from you can do this in very given x to y conversion is simple because of h is doing that activity, but h inverse is not possible, right? So from y you cannot get x. That's from a small string you can't get biggest string, right? So that's security property. We studied that, right? And then we have looked at second pre-image resistance and collision resistance. Collision is something like this, right? What are you converting from big string to smaller string, right? So this is bit is, of course, when it's a bit string, it's a combination of zeros and ones. And number of combinations, such combinations with say this length could be very large, and this is smaller length output. So we are doing this kind of mapping, right? So if one output can be mapped by multiple inputs, right? So multiple strings may map into this one. So that's called collision. Okay, but hash function is such that having a collision is very, very less probability. It's impossible to find collision. So that's called collision resistance. But when there is a one-way mapping and it's kind of compression, lossy compression, then there has got to be collisions, right? So you understand that, right? We have done this in detail. So what is the use of this function, hash function, in cryptocurrencies? There are two main functions. One is a message digest. Okay, we create a small digest because the output is smaller, so we can always see that the output is that we store is same as you regenerate it, right? So in some sense you can check the integrity whether the file is changed or not. Okay, there's one use. Okay, and then we use hash also for puzzle friendliness. Okay, now this is very interesting concept that see, crypto mining is, there's a concept of crypto mining. Anybody can do crypto mining. You can do crypto mining. It means that you can generate crypto coins, okay, or part of crypto coin, right? But that requires you to solve a puzzle, and this puzzle is in the form of hash function. Okay, so we'll look at that in the next class, right? Meanwhile, I will request you to please read this when you have time. Okay, the next thing that we do use, we use hash is called hash pointers. Okay, now the pointer, right? You would have studied in your programming languages, and you have used pointers, right? Pointer points to another data. Pointer is a data which points to another data item, right? So the simple pointer like C pointer. Okay, and then while hash pointer we define as an element, or it has is a tuple wherein first is regular pointer. So we can see hash pointer has two elements. One, first is the regular pointer which points to data, and second is the some other element which is the hash of this data. This is the data, you take some hash function is known, h, take hash of that and put it here. Okay, so this element which is hash pointer has two elements. First is regular pointer and second is hash of the data it is pointing to, this data. Okay, now what is the use of that? Now we have this data available, okay, which is visible to everyone and modifiable by everyone, and suppose somebody changes this data, right, then this, and when you check the integrity of this and do the hash of this thing, this whole block or this data, then it will not match with the hash value available in the pointer. Okay, now we'll see use of that in data structure which is called blockchain. Now what we can do is that we create the first block, which is nothing but, we'll look at the structure of block later, but consider this as a data item. Okay, it says, or it has some number of zeros and ones which we treat as data. Then we do what we do. Okay, we then calculate hash of this. Okay, and keep the value here in the previous block. Okay, right? So what okay, so this diagram is actually consider this is the first data and this is second, this third, and so on. Okay, so let's assume the block of some size, right, fixed size. So first block is over, you calculate the hash value of that, and when you start the next block you just keep that value here, and then the second data items will come, second block's data item, and then again calculate the hash of this. When you add the third block, keep the value here, and so on. So this is the last block, and then you calculate the hash value of this and keep the hash value here. Similarly, okay, all right, this hash pointer could be null, because if this is the first block or genesis block. Is it clear? So what it creates is a tamper evident lock, right? I mean, anybody changes anywhere, then it means that his hash pointer has to be changed of the next block, and at the end hash pointer of the which is at the head also is changed. Now if you keep it secure, then this cannot be changed, right? Then you can find out there is a tampering somewhere. Any question? Are you able to understand, Advait?
Yes, sir.
Okay, all right, let's move ahead then, right? So this shows how tamper detection can happen. Now these are the blocks that are coming into blockchain. One after other blocks are coming in. So you are doing a transaction, and the transaction will become part of this. After a certain number of transactions, a block will be formed. Okay, we'll see how blocks are formed later. And when this block, enough data is there, then block can be formed, and then its hash is calculated, and then hash comes here in the next block. So this is the first block, the second block, third block, fourth block, fifth block. This is the last block right now, current block. Can't say last, is a current block, right? All right. So now if there is a data change here, if adversary has made a data change here, then adversary has to change this pointer, otherwise it will be detected. Okay. Now, so let's assume it does change here also, which is very difficult though in blockchain. Then obviously, this now there is a this pointer is also be changed because the hash of this complete thing, right? And it means that now in this way, finally this has to be changed by adversary, which is not possible. Okay, so note that what we are doing here is when we're creating these blocks, we are actually is a hash of the whole thing we are taking, which includes a pointer itself, and putting it here. Okay, this could be whatever, first blocks, it could be some value or null depending on implementation which Bitcoin has taken. But try to understand the concept, right? And then when this block is formed, it already has a hash pointer which points to earlier block. Then take this and then calculate hash and keep it here. That way you can create a tamper-proof system. All right. Any question?
No, sir.
All right. So let's go ahead, right? How do you make sure that data is actually coming from Alice or anybody? Now, of course, I mean, it's not truly correct because in crypto, we don't use names. We can say Alice is using, but she will not say her identity is Alice, right? It could be anything. It could be any, is a number actually. Okay, so we use digital signatures and we understood it, right, very well because we studied it. So digital signature has, the process, again, we are just, those of you who have forgotten, we are repeating it. Please go back to the slides, whatever lecture we have studied it. First thing what we do is that, note that we are using asymmetric key encryption. Now we call it public key encryption, right? And there are various schemes available for that. Okay. So what we do first is that we create a key pair, which is a private key, which is secret key we call, and then public key. So SK and PK we note that there is a way to create this. These are not two independent numbers, right? We know that there's a relationship. Okay, all right. So once we have available this SK and PK, the next thing is that message. If you have to do signature on something, okay, then that message or content must be available, because it's a signatures are non-transferable. It means that we are doing signature on a particular piece of data. So we are doing signature on message M, okay, using secret key SK, okay, and then we sign it. Basically we do encrypt, and then as a result we got signature, okay, which is sigma. Okay, the next step is that now at the other end, or so what we have sent now, we have sent as a process, we have sent to somebody else message M, original message in plain text. Okay, we have sent signature, which is which is private key encryption of that message, and then we have also communicated private key, a public key, PK. Okay, this available, only then it can be decrypted, and based on that it can verify. Basically what will do, it will use this on signature, and then there is some comparison, okay, to find out whether it's the output matches with original message M. So there are multiple steps, right? We can do hash of message and sign it and check it, whatever, right? But right now we just say that once public key is anyway available, once signature is available, we can verify is original message or not, okay, or yes or no. Okay, so this is a digital signature scheme, right? Okay, all right. So it's simple, as simple as that. First step is generate private key, secret key and public key. Second is publish PK, so that PK is available to others. Okay. And third step is take a message M, then get the signature using signature scheme, is encryption plus whatever. Then send message M and signature, and PK anyway is available, which is public key, and then you verify. That's what we studied, right? Okay, so these are popular schemes that can be used. Bitcoin uses elliptical curve encryption schemes, right? So this one it uses. Okay. Of course, we have not studied this. We have studied RSA, LGAML, etc. But just understand how it works. It's basically working is same. If you understand private key, public key pair and how it can be used, then you can make out. All right. So these are the basic things that we do. These are the basic, what do you call that, building blocks of cryptocurrency as well as for blockchain. Now let's get into basic introduction to Bitcoin. So a lot of confusion over Bitcoin, right? And because a common person, even the user, in the most cases cannot understand what is the technology behind it, what it's trying to do, how it is getting linked to actual money, right, in dollars or rupees or whatever, right? Okay, so there's a lot of confusion. Is Bitcoin a money? Is it legal? What is identity? My name is Ravi, right? But I cannot use this identity. Okay, because identities are confidential, and my identity on Bitcoin ecospace can always change. Okay, every few minutes, maybe every half an hour, I can change my identity. Okay, is it distributed or centralized? Is there a concept of centralized anytime, anywhere? Okay, all right. So these are the question. What cryptography we are going to change? What is blockchain, and how it's different from Bitcoin? Is most of people are confused about it, right? So let's try to understand it. Crypto in general is part of mathematics, right? It has been very tough. So very few people really went into details of how crypto works. But crypto earlier was meant for cryptography. Okay, and also there's a conference called Crypto, which is by name of Crypto. So these are two things that which we are aware of. But now crypto word also means that the Bitcoin and blockchain or cryptocurrencies in general. Okay, when you say that crypto, then depending on the person, it will come into the mind cryptography. But most of the people, outside computer science or mathematics will understand this is cryptocurrencies like Bitcoin. Okay, so cryptocurrency is completely digital, formless currency that is tied together using computer science and cryptography and economics. There are three keywords here: CS, cryptography, and economics. Because CS, because it's totally based on computers and internet. Okay, internet is a medium of transmission, but computing, because without computers you cannot have cryptocurrencies. It's not a physical currency like Indian rupees note, paper note or whatever. It's not or coin. It's not that. Okay, you don't have a silver coin with which is a Bitcoin. It's not. Okay, it's all digital currency. Okay, so Bitcoin, of course, is the most popular cryptocurrency, right? And there are more than 200 cryptocurrencies available, and Bitcoin happens to one of that. Ethereum, etc. You would have heard of those things, right? And blockchain is nothing but data structure that we just studied, right? Is a method of storing data among multiple parties that ensures data integrity without requiring trust. So we'll come to blockchain little later as well. Okay, so cryptocurrency is a digital currency based on computer cryptography and economics. Okay, and data structure that we use for storing data, storing blocks of data is blockchain. Now, blockchain is not a centralized thing. Note that the word, okay, we are not use the word here. It's not non-centralized. We'll look at that. So transition is not happened, but Bitcoin has also come into play. Okay, so we know physical cash. When we say our currency, it means that currency that we use now. Physical cash is what we use every day, right? What are the issues with physical cash? Okay, when people do illegal transactions, for example, if somebody is selling drugs, okay, we'll never take check from you. If you want to buy, say for example, marijuana, okay, it's illegal in the country. So if I want to buy, and if I pay by check, or I'll say I will do Google transaction, the person will refuse, because is it somewhat traceable. Okay, but physical cash is untraceable. You give the rupees, you will accept Indian rupees, right? Because where that rupees, who has given, where it has come from, where it will go, nobody knows. Okay, so it is convenient, but it's not really traceable. Okay, so non-traceability could be good for criminals. Okay, we'll see that cryptocurrency is also not traceable, so it's good for criminals. Okay, it's secure, yes. I mean, you have Indian rupees available, use it for after 10 years. I mean, dollars, for example. I mean, somebody would have bought has a dollar note, taken 15 years back, still it has this value, right? Okay, it's a low inflation in general, but only problem is that directly take Indian rupees and you try to use it online, you cannot use it, right? You need to convert, you'll have to store it in bank, and then you can use that rupee, which is form of which becomes now in the form of digital, can be exchanged, right? So there are the issues with physical cash is that it is largely non-traceable, is secure, but it's inconvenient. It cannot directly be used on online. While credit cards is partly secure, not all transaction, fraudulent transactions that can happen on credit card will get the money back. Okay, digital transactions happen. Okay, you don't need to swipe the card always, right? I mean, you can use it online, but it is always tracked by banks, because credit cards are linked to banks. Okay, and then we have electronic credit and debit transaction like Google Pay and Amazon Pay and UPI and all that. Banks see all this transaction because bank is a party in between. Whether Google Pay or whatever or UPI is a bank, and is your bank usually, right? I mean, I have account in, for example, SBI or HDFC. Google Pay will be finally land up there, and the money will be transferred to merchant, right? Okay, so these are the traditional way. Alice has a credit card. Bob doesn't have it. Bob wants to use credit card for some transaction. Alice will give the number, credit card number, and Bob will use that. Okay, other method is that Alice wants to help send some money to Bob. She will instruct bank to transfer the money to Bob's account. So Bob will get the money that way, right? What is the problem here? Problem here is there is a bank always in between, which we call is trusted server. there's a concept of trusted server. Okay, so for transactions that are happening today, whatever means we are doing, there is a need for a bank or trusted server. So basically, it's a trust on financial institutions. What is another problem? High transaction fee is quite high. You do, you go to another country and try to change Indian rupees into that currency, and you'll see that your almost 10% money is gone. Between intercurrencies, between currency in, for example, India and the currency in, say, Britain, you will see that significant amount of money goes in conversion. Okay, then you will realize it when you go to US and take Indian rupees, that you'll find, or use Indian credit card, they take directly, I mean, I've used it several times, they directly take 4%. Europe actually takes 6% money for the transaction, right? So this is the second problem. Third problem is no anonymity. Everyone knows where the money is coming and going. Okay, all right, when I'm doing transactions, the bank knows that I'm doing the transaction. All right, so these are the problems. Now, from government perspective, these are not the problems. Anonymity is not a problem. Okay, but I may think, why government should know that I have done this, where I have gone, what countries I have gone, and so on. So banks are nothing but government, because governments have control over banks in general, and they pass on all information that's needed by government, right? So I may want to avoid this. So these are some problems, right? So now we see, for everything there is a concept of bank. So whether it's cash or credit card or whatever, right? Or UPI and so on. And then situation was there till 2008, when there's a great gentleman called Satoshi Nakamoto written this excellent paper. Okay, you can go to this paper, you can download and go. Okay, and then introduce the concept of Bitcoin. Okay, so now Bitcoin can do transaction without involving bank, which is peer-to-peer. Okay, all right. So it is not trusted. It does not use a trusted party. Okay, all right. And reason for Bitcoins coming in is that ideological. Like, I may not want government to know what all I am doing. I don't want to involve banks. I don't have trust on banks. Okay. If, for example, banks can go bankrupt, what will happen to my, say, let's assume if I have 1 crore in my bank, and bank goes bankrupt, and it happens several times in the country, what I am going to get back? What is the maximum guarantee? Is 1 lakh. Okay, I will lose my money, right? So I may not want banks to come into play. Okay, and of course I want to avoid fees. Why should I waste my 4% money or 5% money just in transactions? And anonymity, I am not anonymous, right? When I'm or I am pseudo anonymous, right? Everyone will know what I'm doing. So I want to become kind of anonymous. Okay, all right. So these are the reasons. Again, I have mentioned the small fees, fast, comparatively fast transaction. I will not say very fast. Is a 10 minutes or something is time required for transaction, right? So it's accepted in now this old slide, maybe more than this. There's no concept of bank or trusted server, seemingly anonymous, and this is a good timing. In 2008, there was a financial crisis and so on, and people lost a lot of money, so they thought there's a good alternative. And suppose you want to do transaction in, say, one of those countries where the government is not stable. Say, for example, you may want to do it in North Korea. You want to send money to somebody in North Korea. Okay, you cannot do it with traditional method, right? However, you can do it with Bitcoin. Okay, so it's used in non-democratic countries. There are many such countries in the world. Okay, this of course we have covered. Is accepted in thousands of businesses. financial institute. A lot of financial institutes are now dealing with crypto, like Citibank or whatever. You almost all names you can find here, right? So it means that it has acceptability, like companies, like big companies like IBM, etc., also accepting crypto. You can see many known names here. Okay, any question? Okay, all right. No trusted servers means what? See, if there is no bank, we are not talking one bank and a branch, a set of banks, right? Because we treat all banks like just one central bank. If that model is not there, then no central trust entity. When there is a concept centralized thing, then there is a need for trust. Okay. Now we have no central bank or no trusted server. So it means that it has to be then distributed. Right? Now, how can you do in distributed network? How can you do transaction which are trustworthy? Because when it's a distributed network, there can be some people who are cheat. For example, this character could be a cheat, or this character could be a cheat. Okay, all right. So now in distributed system, we will have to come out with mechanisms such that we can do trusted transaction on non-trusted system. Okay, all right. Now another good thing is that everybody can join the system. While in banks, it's not necessary everyone can join the system. You may want to take a membership, or you may want to open an account in one of the most premium bank in Switzerland. They will not allow you. Okay, so now here everybody can join the system, which is crypto system, right? Okay, users are not registered by any authority. Wow, fantastic. Whether it's a criminal or you or anybody else, anybody can be part of this crypto system, right? And then it is peer-to-peer, which is users can contact and transfer money, crypto, of course, crypto coins, directly. Okay, so now these are the things that we want to achieve through a purely peer-to-peer network, which is like this. Every user is connected to every other user. Okay, any question? Okay, so there is no trusted server means that nobody controls the money. It also means that amount of money that will be printed is fixed. It means the number of bitcoins, there's a limit on number of bitcoins. Okay, which is almost like 21 million bitcoins. BTC is Bitcoin. Okay, all right. But we see exchange rate fluctuation in terms of dollars. So we'll come to this slide later. Okay, but you need still client software. Somebody has to develop the software which will let you do all kinds of transactions. Somebody should create a wallet. Okay, so there are a lot of software available for that. It's a client software, and these are the ones, right? And it's well published. You can use any one of these. Okay, and then now this is a system, distributed system. So somebody has to do checks and balances about the processes that are running. So there are methods, right? I mean, there is a Bitcoin improvement proposals are, users can submit, and there'll be voting mechanism, and finally proper process can be formed, right? Okay. Now there is Bitcoin bubble that happened in 2021. The Bitcoin value has shot up. Now note that supply of Bitcoin also happens because one can mine the Bitcoins. One can create the Bitcoins by spending computing cycles. Okay, but now the value of Bitcoin in terms of dollar, in thousands, for example, right? So it's close in 2021. It reached almost like $34,000 for a Bitcoin. While it started with very small You know, just about 15-20 years back, it was less than what, $5, $5,000. Okay, so there is a, and this rate fluctuates very often, right? You, if you read newspaper, then you find the Bitcoin has gone up and down. So now it has become like a share. Okay, ideally it's a currency, but once the demand supply changes, then the value can shoot up, because if you want to buy a Bitcoin, you have to pay in terms of dollars. Okay, and the one who's selling, who has a position of Bitcoins, will charge you some money, and that money changes depending on demand and supply, right? Okay, and there's a huge market capitalization, right? And you know, like I think this was just few days back, I've taken this snapshot. Market cap is phenomenal. I think market cap is this much. I don't know how many trillions, whatever. Is 756 trillion billion, I think 756 billion. Okay, so these are the other currencies, right? Like Ethereum, Tether, BNB, and so on. Okay, so who developed this? Satoshi Nakamoto written this paper in 2009, and it's a lovely paper he has written, but nobody knows who is Satoshi Nakamoto. Nobody knows. Where is he? He has only online presence, whether he's a single person or multiple persons, or but what people understand is that this is a brilliant piece of work that he has done. Okay, so he is involved, but nobody knows who is that person, right? I'm not sure why, but then many people claim that the person is Satoshi Nakamoto, but nobody could prove it. Okay, so 2008 he has done this paper, and 2009 came reference implementation. Okay, and from his name it looks like it's a Japanese name, but nobody knows actually who is he. Okay, all right. So, and Bitcoin, he has also created you know, sub Bitcoins, or you know, like coins, you know, small coins, or part of it. So one BTC is 10⁸ Satoshi is all right. So market cap is yeah, 737 billion approximately, and one BTC about $38,000. Okay, so where is the value for BitMoney come? BitMoney comes because it's people expect the other people to accept it in future. It's essentially a computing cycle people have spent to create Bitcoin. Okay, but you might have created so many cycles to create a Bitcoin, but if nobody cares, then Bitcoin value will be zero, right? Because it has acceptance, hence it has a value. So many people say it's like any other currency. The skeptics say it's a Ponzi scheme, right? Okay, it's just fraud. Nobody knows, right? But still it's in use, so it's kind of popular. Now Bitcoin design principles will go for next 2 minutes and very short. Okay, we'll not go into detail, just 1 minute I will spend. So what we need to first do is to find out what is Bitcoin identity. If I'm opening a Bitcoin, what is my identity? It's nothing but I have to create a key pair SK and PK. Okay, SK is secret key which I cannot tell anybody. So PK is my identity. So somebody wants to transmit me money, they have to transmit it to PK. And using SK, I can actually derive the money. Okay, so PK is to be known to other people, but I can change PK every 10 minutes or whatever. So my identity can change. Okay, so my money that has come to my PK has now to come to new identity when I create. All right. So my identity is public key. Okay. So what is so we transact using public key, and of course we use escape for signature. So that is identity, and then we have to take care of double spending. I mean, if I have money, digital great thing about digital thing is that I can multiple copies, right? You have a file, you can create hundreds of copies. Unlike paper, you have a book, paper book, creating 100 pieces of that is difficult. Okay, so what mechanism should be there that there is no double spending? Like you have physical paper note, you cannot photocopy it and then make multiple copies of that, right? It's very difficult, right? While digital thing you can copy it always, right? Then there must be way that you cannot send this money to multiple people. So there must be some way. Okay, then they should not be stealing. So Alice is sending money, right? Then 2D cannot assume the identity of Alice. 2D cannot send this money on behalf of Alice. That's the second challenge. And then there should be some way to create the money, fair money creation. Okay. So these are the things that we'll study in the next class, and for that we have like cryptographic signature with that, such that nobody can steal. No double spending means that we have global ledger which is distributed, and that we call as a blockchain. And then there's a way to mint the money using something called proof of work. Okay, and the question is that how can we decentralize this? Because the whole network works in peer-to-peer model. Okay, so this is the concept. So we'll start from here in the next class. Basically here design principles, and then we'll go on. I think we will need 1 more hour. Basically 2 more hours. So we'll have an extra class. I think sometimes in this week. Okay. All right. Any question? Are you able to understand it, the basic concept?
Yes, sir.
Okay. So in the next class, we'll try to cover more things, and at the end, we should have fairly nice picture in mind how whole thing works. All at very top level. We're not going to get into details, too much of details. Just try to understand the basic concepts. All right. Thank you.